All right, in the last part of today's video reference, we're going to learn about reflecting figures. So reflections are basically a fancy word for flipping figures, and every point is flipped or reflected over the line of symmetry. So we always have to identify what's that line of symmetry. Many times when you're reflecting, you're either reflecting over the X or Y axis. So let's look at this example here. You can definitely see, I'll do it in pink, this is the new figure. Someone tell me which axis is which, so we'll call this A, B. Can someone tell me which one, for example, is the y-axis? Yeah, so over here, this B, if you will, is your y-axis, and that means this needs to be the x-axis. So looking over here, is this flipped over the x or the y? Definitely flipped over, or reflected, I should say, over the y-axis. So I'll write here, this is a reflection over the y-axis. In the space above, let's write the coordinates of the two triangles and see if we notice any type of pattern. So I already did A, B, and C. So the new A prime, B prime, C prime looks like this. So this is -3, 1. B prime is -5, and then it goes up 10. And then C prime is -5, 1. So I'll pause this and see if you can find any patterns if you look at the X's and Y's for the pre-image and then the X's and the Y's for the image. All right, did you notice that when you reflect over y-axis, y stays same? And what happened to all the x's? If you look here, 3 became -3, 5 -5, 5 -5. So we'll put here x. X's are opposite. All right, so just to finish this up, again, you're flipping every point. So if you were to actually flip it over, you count to your line here and do the reflection 1, 2, 3, 4, 5 spaces, and then 1, 2, 3, 4, 5. Same thing here, 1, 2, 3 to the line, reflection 1, 2, 3. Possible lines of symmetry. We'll start off with the easier ones. We're just using the X axis, which is your horizontal axis, or your Y axis, which is your vertical axis, and you're reflecting over those. But there are a lot of times when they'll give you an equation as a line of symmetry. So that could be like y equals 3 or x equals -4. So let me quickly show you y equals equations versus x equals equations. So, and that's the bell. So if you look here, if I graph a y equals like 3, it gives you a horizontal line all the time. Same thing here, say I did y equals -2. It's always horizontal because if you think about it, your y coordinates will be -8 and then -2, -6 and -2, -4 and -2. When y equals -2, you get a horizontal line. Vice versa, if I did, like, let's say x equals 4, can anyone predict what that's going to do? Yeah, it'll be vertical at x equals 4. And -4 would be over here, vertical, -4. So again, all the x-axis, all the x equations here will give you vertical lines. So it's almost like it's the opposite of the axis, because the x-axis is horizontal, but x equals equations give you vertical. And then again, if we talk about the y equals equations, it's again the opposite of what the y-axis does. The y-axis, we all know, is the vertical axis, but y equals equations are always horizontal. So if we were to flip a figure over, let's say we were flipping it over right here at the point -2, 6. We'll put a point right here on the board, and then we'll end the video here, and we'll talk about what that would look like if we reflected over y equals 3. I hope this video was helpful, and hope it's still recording to the end, and thank you.